This is a guide reading for Chapter 18, Sections 1 through 5. So go ahead and open up your books to Chapter 18, page 514. And you need to read 18.1. And one of the numbers that you should be familiar with is what the charge of one electron has, and that's in the middle of the page. That is on your table of information, but it's one of those ones that's kind of handy to have bounce around in your head. Also, notice the magnitude of that and the unit, but go ahead and read 18.1 and make sure you understand the equation Q equals NE after you're done reading. If not, ask about it. All right, welcome back. If you didn't look at example problem 1, that is something you do need to look at. That is the whole Q equals NE idea. So make sure you're okay with getting numbers of electrons. Okay, now let's take a look at 18.2. Don't get, you are going to read all of 18.2, but don't get too caught up in if it's a negative or positive charge when you rub glass on fur or whatever. The important thing is that you realize that what's actually doing the moving is the electrons. The protons are staying put, but the electrons are moving around. So if something picks up a couple more electrons and it started out neutral, it now has a negative charge. The thing that lost a couple electrons and started out neutral, of course, now has a net positive charge. So go ahead and read 18.2. Welcome back. There was also some interesting stuff in there on how electronic ink works, at least according to our book. This is something that's actually taken off quite a bit lately. If you've heard about the Amazon Kindle or the Sony ebook reader, there's the way to understand a little bit on what's going on with that digital ink, which if you've ever seen does look very similar to paper, way better than reading from a computer screen. Okay, so that was it for 18.2. On 18.3, you do need to have the gist of what's good or what makes a good conductor and what makes a good insulator. And they make an analogy, of course, to heat and flow of heat and all that kind of nonsense. But just make sure you're aware of what's, what constitutes for charge, okay, what constitutes a good conductor and a good insulator. Obviously, this can be different than when we're talking about insulation in your house. We're talking about an insulator for electricity or a conductor of electricity, to put it very, very broadly and vaguely. Okay, so go ahead and read 18.3. Welcome back. There's one sentence in 18.3 I want to point out. It said, and this is in the first, second, third paragraph, it said, it's about halfway down, it says, the exact number of electrons detached from each atom depends on the nature of the material, but is usually between 1 and 3. Okay? When one end of a conducting bar is placed in contact with a negatively charged object and the other end is in contact with a positively charged object, the free electrons are able to move readily away from the negative end towards the positive end. Okay? Don't get this confused with current. We're going to talk more, there is a relationship here. We're going to talk more about current later on. So don't think that current is the flow of electrons. Current, we'll get into why that is a little bit messed up, but we'll talk about current when we get to current. So just hold off any notions of what current is for now. All right. In 18.4, this is probably the most difficult section of these first 5, and this is charging by contact and charging by induction. We've talked about this a little bit in class, but let me give you a brief reminder that charging by contact, literally you have, let's say you have a neutral object and you have a negative object. You touch the negative object to the neutral object and you can give it a negative charge. Okay? The charging by contact is pretty straightforward. The objects actually touch. The charging by induction is the part when you're reading this you need to pay special attention to the process by which you can get something to charge by induction. And like I said, we are going to talk about this in class briefly, but you do need to make sure that it all makes sense again, presented in a slightly different way. Okay, so go ahead and read 18.4 and make sure you also look at the pictures on how, what the molecules, the analogy for the molecules in figure 18.8. But go ahead and read 18.4. All right, welcome back. 18.5 is Coulomb's law, and this is very similar for the equation. Go ahead and look at the equation about halfway down the page where it says F equals K, Q1, Q2, magnitudes over R squared. And that looks really familiar. It looks a lot like gravitational force. Okay. Instead of big G, we have a little k. Instead of two masses, we have two charges, or two values of charge. And we still have R squared. Okay. Now, a couple big differences. You should be aware that what little k is 10 to the ninth, and big G is 10 to the negative 11th. So the constant is drastically different. Okay, so over small distances, guess what's going to dominate forces? It's not gravity. It's going to be Coulomb's law. Okay, and this is what helps keep things together on a molecular level. There's also the weak nuclear force and the strong nuclear force, which we'll talk about later. But Coulomb's law is part of that keeping things together. For Coulomb's law, that gets you the magnitude, okay, that equation. To get the directions of the force, it's just like everything else. You got to draw a picture. You might have to deal with components, etc. Okay. But the equation to get a magnitude is literally just plug and chug into there. But then there might be complications with angles and stuff like that. So go ahead and read. Oh, and sorry, almost forgot the biggest difference. You can have attractive forces or repulsive forces. With gravity, you only have, of course, attractive forces. So now we can have a force repel, okay, which also affects the direction. So that equation there is only for the magnitude. The direction comes from your picture and thinking about what's going on, okay? So go ahead and read 18.5 and make sure you walk through the example problems because it's a good, one of them is a good review of circular motion and the other one just shows you the units and the equation and the magnitudes of these kind of forces. So go ahead and read 18.5. Oh, and there's another one that shows you how to deal with the directions and the signs and the angles and everything I mentioned before. So read 18.5, but really pay special attention to those example problems and try to follow along with what they're doing. Welcome back. That concludes 18.1 through 18.5. The rest of Chapter 18 is going to be in a separate guided reading later on. Thank you.